Picture a planet glowing a peaceful deep blue. Looks serene, right? Maybe even inviting? Well, if you were to actually visit HD 189733b, you wouldn't find a drop of water. That beautiful blue? It's actually silicate glass. And in this incredibly hostile atmosphere, that glass is raining down. But it's not falling straight down, oh no. It's being whipped completely sideways by monstrous winds blowing at 5,400 miles per hour. We're talking nearly 7 times the speed of sound. Just imagine being caught in a hurricane of shattered glass moving faster than a fighter jet, all while in 1,700-degree heat.
But you know what? That glass shredding nightmare is literally just the beginning of what we've discovered out there in the deep universe. In this explainer, we're going to escalate through the absolute most terrifying, hostile environments confirmed to exist. And stick around because I promise you, by the end of our journey today, we're going to visit a planet whose reality is so apocalyptic, it is actually hotter than most stars.
Section 1. The Cold and the Dark. Okay, let's dive into this. We're starting our journey in the first tier of planetary danger, places where the universe strips away warmth and light entirely. The worlds in this category are defined by an eerie, haunting emptiness.
Take a look at Earth's coal on the left, one of the darkest natural substances we know of, and compare it with the exoplanet TRES-2b on the right. This massive gas giant reflects less than 1% of the starlight that hits it. To put that into perspective, this world is physically darker than coal, and it's even darker than black acrylic paint. It absorbs almost all visible light, and scientists actually believe this is due to some truly bizarre, still unknown chemical compounds saturating its atmosphere.
But here is the detail that really makes TRES-2b unsettling. Because it absorbs so much energy from its star, the planet is incredibly hot on the inside. So against the pitch-black backdrop of deep space, this giant sphere of absolute darkness actually emits this very faint, ominous red glow from its extreme internal heat. It's kind of like an ember, slowly burning out in a dark room.
All right, let's move 21,500 light-years away from that dark ember to OGLE 2005 BLG390LB. Check out this massive negative number, negative 370 degrees Fahrenheit. This is the reality of orbiting a very dim star at a massive distance. It just completely transforms a planet into an absolute frozen wasteland.
To really conceptualize just how punishingly cold negative 370 degrees Fahrenheit is, we have to look way past ice or snow. At these temperatures, basic atmospheric gases just cease to function as gases. This planet is so relentlessly freezing that nitrogen, the gas that makes up almost 80% of the air you are breathing right now, would instantly drop right out of the sky and freeze into a solid block on the surface.
Section 2. Bizarre physics and crushing pressure. Leaving the freezing dark behind, our second tier of danger introduces us to totally baffling scientific realities that challenge everything we thought we knew about planetary physics.
First up in this bizarre tier is HD 2782b, a planet defined by the most extreme eccentric orbit in the known universe. Within a single year, this world violently swings from a freezing outer orbit way beyond where Mars would be, to an incredibly scorching close pass inside a Mercury-like orbit. Imagine the atmospheric chaos of a planet being repeatedly flash-frozen and then rapidly deep-fried, year after year.
Now, what's really interesting here is this concept of hot ice on Gliese 436b. This planet has a surface temperature of 800 degrees Fahrenheit, which, obviously, should easily boil away any water. But because the planet exerts such massive crushing gravity, it forces the water molecules together so tightly that they literally compress into a solid state. It's a terrifying physical paradox, solid ice burning at 800 degrees. We have absolutely no equivalent for the state of matter here on Earth. Let's introduce extreme proximity to a star into the mix. Just 40 light-years away sits 55 Cancri e. This planet orbits its host star a staggering 25 times closer than Mercury orbits our own sun. At that insanely close range, the surface temperature pushes an astonishing 3,900 degrees Fahrenheit. That is hot enough to effortlessly melt metal right on the surface. But because 55 Cancri e is extremely carbon-rich, that monstrous heat is paired with equally monstrous pressure. The result? Well, the extreme physics of this world have likely caused the planet's internal structure to crystallize almost entirely into solid diamond. It's a gorgeous concept on paper, right? But it's a completely lethal, metal-melting reality in practice. Section 3. Lethal rains and molten oceans. The bizarre now gives way to the purely chaotic.
We're looking at apocalyptic atmospheres where the very weather systems are violently hostile to any form of matter.
Think about a typical rainstorm here on Earth. Now compare that to the absolute horror happening on Coro T7b. One entire side of this planet is completely covered in oceans of liquid churning lava. The heat is so intense that the rocks literally evaporate. They turn into a gas, drift up into the planet's atmosphere, and then, as things cool slightly higher up, that gas condenses and it rains pebbles and jagged rocks right back down into the lava ocean. Literal rock rain.
Which brings us right back to the world we opened this explainer with, HT 189733b. Notice how stark the contrast is here. The appearance is a peaceful, deep blue, but the reality is wind moving at 7 times the speed of sound, hurling sideways silicate glass rain at 1700 degrees. It perfectly captures how a beautiful visual from a distance can mask an insanely violent reality up close.
And this brilliantly illustrates our next weather nightmare, WASP 76b. This planet is tidally locked, meaning one side always faces the star. The day side hits 4,350 degrees, which is hot enough to boil raw iron directly into a gas. That iron vapor then drifts toward the twilight zone. Once it hits the cooler night side, it condenses back into liquid. The end result? A permanent, never-ending rainstorm of liquid iron falling from the sky in the dark.
Section 4. The Ultimate Cosmic Nightmares. The environments we are about to look at totally transcend bad weather and bizarre physics. These are the 2 most extreme, apocalyptic planetary realities ever confirmed to exist by human science.
This is a truly grim cosmic story. PSR J1719-1438b is technically a planet now, but it wasn't born that way. This world is actually the crushed, exposed, dead core of an ancient star. It was slowly and violently cannibalized over billions of years by a nearby pulsar, which stripped away everything until only this insanely dense corpse remained.
And the conditions on this stellar corpse are pure nightmare fuel. Look at these stats. It's trapped in an orbit around that same dead pulsar, completing a full year every 2 hours. It is constantly bathed in a blinding wash of lethal radiation, and the gravitational crushing force of its history makes it denser than solid diamond. It is the ultimate hostile environment, literally trapped in the grip of the star that killed it.
Which leads us, finally, to the climax we promised at the very beginning. Just let this massive number sink in for a moment. 7,800 degrees Fahrenheit. This is Kelt 9b. It is the absolute hottest exoplanet ever discovered in the history of astronomy.
So, the crucial point here is exactly what we teased earlier. KLT9b is hotter than most actual stars in our universe. It is a planet that totally defies the very concept of a planetary surface. It has absorbed so much thermal radiation from its host that it practically blurs the line between a planet and a burning sun.
And the sheer apocalyptic destruction happening to Kelt 9b right now is just hard to fathom. The heat is so astronomically intense that the planet's atmosphere is actively boiling off and being blasted away into deep space. The forces are so violent here that heavy metals cannot even exist in a solid form. They exist entirely as a gas, swirling around in a glowing, superheated storm.
As this quote from the source material beautifully summarizes, somewhere out there, one of these worlds is still raining fire, glass, or metal right now, and we're only just beginning to find them. These aren't just theoretical models on a chalkboard. These are real places, enduring real extremes, existing at this very second while we sit safely here on Earth.
It definitely makes you appreciate our calm blue skies, doesn't it? But it also leaves us with a profound sense of awe at the absolute hostility and scale of our universe. So I leave you with this. Looking at all the impossible extremes we explored today, which of these cosmic nightmares is most terrifying to you? And honestly, more importantly, what else is waiting out there in the dark for us to find?
If you enjoyed this video, don't forget to like, subscribe, and turn on notifications. Join Beyond Unknown for more incredible mysteries of space and science.